So if you recall, the very first thing we learned on lesson 25 was when you had the little TV, we try to draw it all out. And then we just try to figure out what was the degree of the focus of view, right? Or view of focus. Field of view, that's it. FOV, field of view, and that's basically what you're trying to find. Depending on how far or close you are to the screen, and depending on how wide the screen, what is that field of view? So that's what this first question is asking. So it says a person is sitting directly in front of a movie screen that is 80 inches wide. They are 10 feet away from the screen. I do provide you a formula. The only thing that makes this formula a little bit different than what I was provided for you on the stuff is this was half of the width, and then we divide it by the distance. That's the only thing. But when I typed it in, it made it out. Which is actually it's the same formula on how halves work here. But it just put the two there. So I mean the same formula, just we took half the width first and then took that and divided by the distance. All right, and this again, it just wants to know what is that horizontal field of view, theta in degrees. Couple things you need to watch out for on this problem. Notice that the screen is in what? And the distance is in what? It does not matter which direction you go, but they all need to be the same unit. So they all need to be inches or they all need to be feet. What do y'all prefer?
Let's do feet because they're small.
Okay, that's fine. Feet or inches doesn't matter to me. So the only thing I need to do is how do I convert 80 into feet? Divide by 12. So go ahead and do that for me. I would also suggest keep it as a fraction. If you try to do it a decimal, you'll get the wrong answer. So it was 80 divided by 12, simplify that. Try to keep it as an improper fraction. It'll make your math a little bit easier. Right, but turn that into an improper fraction. When you type in the calculator 80 divided by 12, it should just give you the fraction. Perfect. That's the fraction you would want to keep it in. You're both correct, but if you try to do a decimal, you can't put a repeating decimal in your math. So you're going to end up getting the wrong answer. You're not incorrect, but depending on how you type it in the calculator, 8 and what is that going to be? What, 2/3 or whatever of a foot? If you type it in as 8 2/3 in the calculator, it'll multiply rather than, or not 8, sorry, 6 and 2/3. You want to actually put a plus sign in between mixed fractions when typing in the calculator. So my suggestion, so you don't have to remember any of those techniques, just keep it as an improper. So again, all you have to do is simply in the calculator, just type 80 divided by 12, and it does pop out 20/3. And then there you go. You just make the decision if you want it in feet or inches. So if you do like inches, Elijah, you would turn 10 feet into what? 120 inches, right? But you'll notice we'll get the same answer. So if you want to play around with that and see if we get the same answers, I will tell you as I was reviewing, I went with inches because I just knew 10 was 120 real quick. So I did notice that 12 didn't go into 80. I was like, oh, that's going to be some weird fractions, but it doesn't matter. But yeah, I mean, it doesn't matter. You're going to get the same answer regardless. So, okay, so if we go into inches, then 10 feet would be what? 120 inches. Again, if you want to keep going with the feet, and you'll notice you get the same answer. So, I mean, don't worry about that part. After that, you just kind of have to plug it into your equation. So as of right now, I don't know anything about theta, but I do know my width was 80 inches. So that's going to be half of 80 divided by my distance, which in this case now is 120. So when we work this out, what is half of 80? 40. And what is 40 divided by 120? One third, right? Yeah. Then for a second I thought you said 1/3, but yes, 1/3. And now we have an equation like this. Believe it or not, if you would have done feet, you would also at this point also got 1/3. To give you an idea, that would have been 10 divided by 2, which would have been 5. And then 5 divided by, actually, no, that would have been 80. No, that would have been 20 divided by 3 divided by 2 would have gave you 10 over 3. And then you had 10 over 3 divided by 10. And then when you keep change flip, you would have got 1/3. So even with the feet, you would still got the same conclusion of 1/3. Now, do y'all remember how I start solving for theta? I got to do the inverse. So now this is going to be theta over 2 times tan inverse of 1/3. You could type this in the calculator, or what I like to do is go ahead and just finish this problem off. What would I then do to solve for theta? Times it by 2. Wait, or is that a hand or 2?
I'll say both, whatever that is.
Okay, let me take this phone call and then.
That's like
Okay. All right. So again, to solve for theta, if theta is being divided by 2, I can just multiply both sides by 2. I like doing this because now I can just type this entire thing into the calculator. All right, so that's what I'm going to do real quick. I'm going to trash it. It'll come back. Don't freak out. But if I go to my calculator, I just go to regular calculator, and I can literally just do 2. Remember, the trig button is next to the 7. There's my tan inverse, and I'll do 1 divided by 3 in there, and then hit enter. One big thing in your calculator, make sure it's in degree. Go ahead. This 2 right here. So when it was theta divided by 2, I multiplied both sides by 2. That's where the 2 came from. All right. And so what was the answer here? Good, Josh. I'll plug it in y'all's calculator to verify. Oh, I plugged in. I guess that would be step 1. Then I simplified the fraction. That would be step 2. And then I took the inverse would be step 3. And then I multiplied by the 2. That would be step 4. And then I plugged into the calculator. That would be step 5, which was what again? 8699. I think on the test, it will clearly state either the whole nearest degree or tenths or hundredths or something like that. Right? Any questions here? I will say do pay attention to what it wants it in, because a lot of y'all did miss a question on the last test because it asked you to round to the nearest foot. And I think the answer was like 175, but you got like 174.7 or something like that. And if you didn't round correctly, you got the entire question wrong. So do pay attention to whatever it says it is. So if it wants it to the nearest degree, what would the nearest degree be here? 37. Very good. Okay. Just pay attention to what the question wants. We good on question number 1? You would get the wrong answer. You would actually get like a decimal that's less than 1, which should kind of be like, wow, if it's less than 1, my field of view is like really tiny. And if you put a little common sense to it, you should be like, oh, I forgot a step. So my field of view should probably be, at least more than 10, if not more than that. Huh? Yeah, so just to give you an idea, just so you could see, yeah, definitely not a negative for sure. If you go here, if let's say I did happen to have this calculate in radians, this is the type of answer you'll get. So it's like a number less than 1. So then that should tell you that doesn't look realistic. So then hopefully that's a reminder to you, oh, I need to go ahead and hit the degree there. All right, any other questions on number 1? All righty, let's look at number 2. No, because we always look at a field of view in degrees, so then you don't have to worry about it. So hopefully your previous classmates keep it in degree for you, but they could be those ones that change it to radians and stuff. So always competition. All right. Number two is a lot like what we saw from 25 to 26. In a simulation, the camera eye is located at the origin. That would be the center of its space. Cube's top vertex is this. I know on y'all's homework, I gave you all the vertices, so you would end up with like 8 different answers. On the test, you only have to worry about doing this to one. And it's telling you, so basically what it is you're sitting here, your camera lens is here, and you have a cube or something out in space. If I have the space's vertex here, where would it be located if my plane is somewhere else? And that plane in this case would represent y equals 2. So again, if the cube is projected onto a screen that's represented by the plane y equals 2, we want to find the coordinates of this new projected point. Let me know when you are ready. This is basically just illustrating to you, this is how the answer needs to be written. Four questions. One more time. Yeah, this was yeah. So this was like the problem set I assigned you, but instead of just giving you one vertex, I gave you all 8 vertexes that you then had to give me 8 separate answers. That was the question you had on your email. Was do I do it to all of them? Yeah, and that's basically what you do. Oh, that's A prime to represent the new located point. So if this is A, this is its new located point. And we do these little prime little things so that the reader, like if there was multiple points, so they can see, oh, this is A prime. Oh, this is where B went. This is where C went type stuff. I try to do that when we try to draw it out by doing like point 1 and then point prime 1 type thing. And it didn't work out, but it's the idea behind it. You ready? All right, so remember the process is if I'm trying to project a point onto a certain plane, then I know I'm looking for something to multiply that vector, some scalar. I don't know what it is yet, but I want it so that my y value ends up being 2. That's about as far as I know, but I can use that to help me find the scalar of this t. So I can basically build a linear equation. So I can say, all right, well, 6t has to equal 2. So how would I solve for t? Go ahead. Perfect. Was that stretching or was that a hand? Oh, I got you. Okay. Like I caught you right in the middle of the question, so I didn't know if you were asking one or not. So then 2 6 would simplify down to 1/3. Again, I'm going to express this again. I would leave it as a fraction. Don't turn it into a decimal because you cannot actually appropriately write 0.3 repeating and get an accurate answer. So just leave it as 1/3. Once you have your results, now take that original point, multiply now every x, y, and z by that scalar to get your answer. So what's 4 times 1/3? 4/3 or 4/3. What's 6 divided by 1, or what's 6 times 1/3? That's going to be 2. That part should have never changed. If you got a different result, you should go back and check this result. And then -2 times 1/3 gives you, very good. And that would be your answer. So basically what you just did is there was another point in space. You had a TV screen right here. You now projected that point onto a plane. Okay? Basically moving and shifting the point. We good? Okay. Number 3 is very similar, but you're going to be given a graph or a picture and stuff like that. Don't get thrown off by the picture. Get real confused. But basically what it is, it's a video game projects a tetrahedron. Does anyone know what a tetrahedron is? It's basically like a pyramid. Kind of looks like this. So this is kind of what you'll see. I'm not a good drawer. That's why I couldn't put it in this program. But you'll see some type of like, yeah, yeah. There you go. So there's like your XY plane or XYZ plane. There's going to be some type of screen here, and then you're going to have a tetrahedron This is my best attempt at it. It looks like a pyramid is what it basically looks like, some type of prism. And then you're just projecting it onto this screen. So don't get too bogged down by what picture is showing to you. The math is still straightforward, right? Again, it's just a video game that's being projects this tetrahedron onto a plane x equals 1. And with the camera eye at the origin, basically just stating that your eye is the center of the universe. And then one of the vertices, we'll call them C, has a coordinate of 480 in this situation. And we're simply just going to find the coordinate that projects C prime onto the x equals 1. So it's exactly like number 2, but it's going to give you like a drawing and a figure of it. You don't have to change the drawing or do anything with it, but it just kind of gives you a visual. And I don't want that to really throw you off. But it's the same process. If you take that point that was given to you, you're looking for some type of scalar so that now my x is equal to 1. So I can use that information to now build a equation from it. So I can come over here and I can say, all right, well, go ahead. I am, yeah. So I'm writing it out. So this will now be 4t equals 1. How would you solve for t? Divide by 4. Yep. And then once you have that scalar, you just simply take that point given to you and multiply each variable by the scalar. So 4 times 1/4 would be what? 1. 8 times 1/4 would be what? 2. And 0 times 1/4 would be what? 0. So that would be your new point that's going to be located on the screen that's given to you. We okay with this process as well? It is. It's just, it's worded differently, but you're going to be given a way better drawing than this one, obviously. But that's basically what it's wanting you to do. Take this 3D image, put it on a two-dimensional plane. What would that look like? We all good? Alrighty. So then the fourth and final question says an object is located at a certain coordinate, and then you first have a rotation and then a projection. All right. So this is that last part we did last Wednesday at the beginning, or maybe it was Tuesday at the end. I can't remember now. But the first thing you need to decide is you need to develop a 3x3 matrix that has a rotation around the z-axis. Right. Now it's not going to be word for word, so be able to do any type of rotation around any axis. If it's a z-axis, what do I know will be a true? Where will be 0, 0, 1? What row and column? But yes, you are talking. Yes. Very good. Very good. The third row and third column. But if it was the y-axis, where would the zeros and ones go? It'll be the T, right? Row 2, column 2. And if it was the x-axis rotating, it'd be the what? Good, the first row, first column. So just notice that. And then to fill in the spots, we go from top left-hand corner. This would be the cosine of theta. This would be the negative sine theta. This would be sine theta. And then this would be cosine theta. I just realized I don't even think I gave you time to write. So let me know when you'll get caught up and I'll keep going. Yeah. Yeah. Well, I don't know. Define a lot of work. Yeah, it is. Yes, more than all three of them combined. And it wouldn't actually be so hard if they would just tell us what theta is. But we don't have theta, so we have to write like sines and cosines like a whole bunch of times. Because that's what it wants you to do is what is the projection onto x equals 1 after the rotation around an angle? If it would have said 45 degrees, then we just have a whole bunch of numbers that we could plug in and just do math. I do have scratch paper in the back corner there. All right, we ready? So again, first thing you need to do is the rotation first. So multiply the 3 by 3 to the 3 by 1. So cosine, so again, we do row by column. So this will be row. And then, of course, there's only one column. So cosine times 1 would be what? Just cosine, right? If you write 1 cosine, you're not wrong, but that's not what you're going to see on your test. It's just going to be cosine. The 1's just known that it's going to be there. And then this is negative sine theta times 4. So what would that give you? But then realize that this is all together. This is not another element. This is all together. And then 0 times 6 would give you 0. So I don't need to write that portion because I'm adding all those products up. So now I can do the next one. I'll do the next row times the only column. So sine theta times 1 would give me cosine theta times 4. And then 0 times 6. So again, you don't have to write the 0. Go ahead, ask the question. So row times column. So it was cosine times 1, which gave me cosine. Negative sine times 4, which gave me negative 4. And then 0 times 6 is 0, so I didn't need to write it. And then this would be sine times 1 plus 4 times cosine. And then, of course, 0 is not needed. And that last one is going to be pretty easy, but 0 times 1 would 0 times 1 would be what? 0 times 1? Okay, yes, the answer would be 6. But 0 times 1 is 0. Okay, make sure we got that part. And then 0 times 4. And then 1 times 6 is 6. Oh my gosh, Luke. Do you understand how to multiply and add? Because I'm just making sure. Okay, okay. All right, so then that's your first step. All right, this is now you took the point and now you've rotated it. Now you need to project it onto x equals 1. So that means I have to find a scalar that would basically turn this guy into a 1. Right? So now we have an equation that's going on. So I'm going to put my work over here, I guess, now. So I now know that cosine theta minus 4 sine theta times t is equal to 1. Does everyone see how that equation came about? And does everyone understand why this trig is in parentheses? Do you understand why? Because if this was a number, I would be multiplying that to t, and what does parentheses represent? Multiplication. So if I knew what theta was, this entire guy would actually just be one single number that would be multiplied to t. So I don't want to just multiply it to sine. I want to multiply it to the entire thing. Right? Now, if I'm multiplying it by the entire thing, how would I then get rid of it? Divide by the entire thing. So now I'm going to divide by cosine theta minus 4 sine theta. Cosine theta minus 4 sine theta. That would go away. So therefore, my scalar would be this guy. And again, if we actually knew what theta was, we would have got a single number. Right, Caleb? Okay, okay. All right, so then you take that scalar, multiply it to whatever the new rotated vector is. So my last step here, I'm going to take my new point that I got from the rotation. And I'm going to multiply it to this scalar. And when I do that, what is cosine theta minus 4 sine theta times 1 over cosine theta minus 4 sine theta? Just 1, because I end up multiplying and dividing by practically the same thing, and I get 1, which is what I wanted. So that should be good. When I take this guy, sine theta plus 4 cosine theta times 1 over cosine theta minus 4 sine theta, I'm just going to end up with a gigantic fraction. So it actually ends up just being sine theta plus 4 cosine theta over cosine theta minus 4 sine theta. And then if I take 6 times this fraction, it's going to be almost like the same concept. It's going to have a 6 and then a cosine theta minus 4 sine theta. And again, if you knew what theta was, this wouldn't look so complicated. You would end up with 3, I wouldn't say nice numbers, but somewhat decent numbers. So that last thing would be the answer. You've now rotated it around theta, and you've now projected it onto the plane x equals
That's
1.
the answer.
I think this one's a multiple choice. Yeah. This would be a long process. I'd be fielding questions. This is where you find the matrices. This is how yeah. I think this one you have to use just a multiple choice. Yeah. Yes. I'm done with the review. Any questions? Okay. Yes. All righty.